Hello everyone, this is my first episode of UnionFind. In this video, I'm going to explain what UnionFind is by following a most simple example. If you are new to the concept of UnionFind, this is the video right for you. Let's begin with an example. Suppose there are n cities labeled from 0 to n-1. There are roads connecting these cities. Each road can connect two cities. Given all the roads information, can you decide whether or not I can get from a certain city, city A, to another city, city B? Let's fill in data to make this real. Suppose there are 6 cities. There are roads connecting them. The roads information is given by a 2D array. Now, the question is, can we get from city 0 to city 4? We can tell from the array the first road connects city 0 and 2. The second road connects 2 and 3, so on and so forth. It is not hard to conclude that 0 and 4 are in the same road system, since you can travel from city 0 to city 2 by the first road, and from 2 to 3 by the second road, and finally from 3 to 4 by the last road. This is quite a short example. However, we can figure out how UnionFind algorithm works by demonstrating with this simple example. Let's transform the description to something more graph theory. The number n means that there are n vertices in the system. The 2D array are bidirectional edges connecting the vertices. In case you don't know, if two vertices A and B are connected by a bidirectional edge, you can get from A forward to B and then B backward to A by the same edge. Now, the question becomes, can you get from vertex 0 to vertex 4? UnionFind, as its name suggests, can be divided into union and find. Our first step, however, is to create an array. This will be the playground to perform find and union later. The array contains n elements, indexed from 0 to n-1. N, if you could remember, is the number of vertices in our context. We are going to call vertex node, because you are going to hear a lot of it. The initial value of the nodes in our array is -1. So, what does the array we created mean? Why did we initialize the value to -1? In our array to perform UnionFind, the value on a certain index is the index of its parent node. For example, in this short array, the value on index 1 and 2 is 0. This suggests that the parent node of node 1 and node 2 is node 0. The value on index 0 is -1, which means it has no parent node. It is a root node. We pick -1 because there is no negative index node in our context. Let's go back to our example. After we initialize the array, by the way, we call the array parent or array P in a short manner. We start to find the parent nodes of the two nodes of each edge. Let's begin with the first edge. 0 and 2 are in the first one. How do we find the parent node of 0? We just visit the index 0 in our parent array, and we see the value is -1. This means it is a root node before we have this edge in our graph. The value of 2 is also -1. The difference in the parent nodes of these two nodes tell us this new edge connects two different root nodes together. To union the two root nodes, we just need to modify the value of one root node to the index of the other one. In this case, we can change the value of node 2 to 0. Let's continue with the second edge. To find the root node of 2, we just find the index 2 on the parent array. The parent of node 2 is node 0. Then we need to go to node 0 to see who its parent node is. The value of node 0 is -1. So node 0 is a root node. The value of node 3 is also -1. So node 3 is also a root node. Let's continue with the next edge. The parent node of 5 now becomes 1. And finally, the last one. The parent node of 0 now becomes 4. After we performed find and union on all the edges, our parent array turns into this. The value of a node is the index of its parent node. If the value is -1, it is a root node itself. Now, by using this parent array, we can know the number of disjointed sets in the graph. Since there are only 2 minus 1 in the parent array, there are 2 disjointed sets in the graph. We can also figure out whether or not 2 nodes are in the same set by performing find on the 2 nodes. They belong to the same set if and only if they have the same root node. To keep everything simple, in this video, I'm not going to introduce union find as a data structure or use recursion to perform find and union. Instead, we just take a simple approach by using while loop to find the root node. This is the pseudocode for find and union on 2 nodes. The process is simple. Find the root nodes of the 2 nodes and then union them together. By using a loop outside find and union, we can perform union find on all edges. If you are new to union find, I strongly recommend you to implement this with your preferred language. In the next video, I'm going to talk about setting up union find as an enveloped data structure and perform union find recursively. Thanks for watching. I'll see you in the next one.